Hey guys, and welcome to the intermediate math video where today we will be covering dimensional analysis. This video is very closely related to the ratios and rates video that Bola uploaded, so if you get confused or you need some extra help anytime throughout this video, please make sure to click on the link that is shown on this screen. Thank you. So in this do now we have two Americans and two Somalis, and they are tasked with lining up from the shortest to the tallest. But as you can see, we have a problem. All their heights are recorded in different units. The first person, their height is in feet. The second person, their height is in inches. The third person, their height is in centimeters. And the fourth person, their height is in meters. Because of this, it is very hard to compare the four heights, so it is difficult to put them in order. Now, a thing that we can use to figure out this problem is dimensional analysis. And today we're going to go over dimensional analysis, so by the end of this video you'll be able to find out of these four men who is the tallest. Now that we have gone over what dimensional analysis is, let's talk about why it's useful. So dimensional analysis is used in everyday life, and it is necessary to compare different units to make problems easier to solve. In addition to this, dimensional analysis can be used to convert any unit such as time, currency, math, length, and volume. We use dimensional analysis every day in things such as shopping or measuring, and it is a key skill to have in life. So I want you guys to work on the do now and try and solve the following problem. So here we have 5 over 4 multiplied by 6 over 3 multiplied by 8 over 2 times 4 over 5 times 3 over 6 times 1 over 8. Now there are two ways to solve this problem, and I want you to figure out the two ways. I'm going to give you some time to work on the do now. Now, one of the first ways we can solve this problem is just by multiplying the numerator and then dividing by the sum of the denominators. So we can do 5 multiplied by 6 multiplied by 8 times 4 times 3 times 1 divided by 4 multiplied by 3 multiplied by 2 multiplied by 5 multiplied by 6 multiplied by 8. Now, if you do this, you will get 2,880 divided by 5,760, which can be simplified to 1/2. Now, although that is possible to do, there is a much simpler way to figure out this problem. So the second way to figure out this problem is by canceling units first. So as we see here, we have the same problem, but before we multiply the numerators and multiply the denominators, what we can do is cancel out the terms. So here we have a 5 on the numerator here, and we can see we also have a 5 in the denominator, so we can cancel them out. The 6 here also cancels out with the 6 in the denominator. The 8 here in the numerator cancels out with this 8 in the denominator. The 4 here cancels out with this 4. And this 3 in the numerator cancels out with this 3 in the denominator until you are left with 1/2. So as you can see, by solving the problem in this way, we can solve it without using a calculator, which makes it much more simple. Now, this is very similar to how we do dimensional analysis, but we will be canceling out units instead of canceling out numbers. So in order to do dimensional analysis, we're going to have to use a thing called a conversion factor. A conversion factor is a ratio that is used to convert between two units. Now, remember, as I said before, you guys can check out Bola's videos on rates and ratios if you need a refresher. The conversion factor can be used to convert units because the conversion factor is an equivalent ratio. What we mean by this is that the two units are equal to each other. So for example, 1,000 meters is equal to 1 kilometer, and 1 kilometer is equal to 1,000 meters. Since the two are equal to each other, we can put them as a fraction where 1 kilometer over 1,000 meters is equal to 1. Since 1 kilometer equals 1,000 meters, it is the same as multiplying by 1 over 1, which would not change the equation. To convert from meters to kilometers, you want to make sure that the desired unit is in the numerator position. So if you want to go from meters to kilometers, since we want to go from meters to kilometers, we want to put the kilometers in the numerator's position. So whenever you're doing a problem, the unit that you have, that you start with, goes in the denominator, and the number that you want, the unit that you're going for, in this case, if you're converting from meters to kilometers, we're looking for kilometers, we put the kilometer on top. So we would do 500 meters multiplied by 1 kilometer divided by 1,000 meters equals 0.5 kilometers. Because the 500 meters and the 1,000 meters, the units meters, will cancel out until you are only left with 1 kilometer. So let's do a quick recap. So if any two things are equal to each other, they are interchangeable and can act as a conversion factor. A conversion factor doesn't always have to be two units such as kilometers and meters. It can just be two things that are equal to each other. For example, if a cow is 120 kilograms, we can say that one cow equals 120 kilograms, and this would be a conversion factor. So we can say that one cow over 120 kilograms equals 120 kilograms over one cow, since the cow weighs 120 kilograms. So the question is, if you have 5 cows, how many kilograms do you have? Now remember, we want to look at what is the unit we're starting with, cows, and what is the unit we want to get to, kilograms. So remember, we always put the unit we want to go to on the numerator. So we want to use this conversion factor since kilograms is on top. So we would do 5 cows multiplied by 120 kilograms over 1 cow equals 600 kilograms. We are left with the units kilograms because the cow's unit will be canceled out. This cow's unit and this cow's unit will be canceled out until we are only left with 600 kilograms. There are a few things I want you to keep in mind while you do the upcoming problems. When doing dimensional analysis, you always want to write units. The reason we want to write units is that if you don't write units, you're going to get confused about what to cancel. By writing units, you can make sure you're on track, and if you keep using conversion factors and you end up with the unit that you want, that probably means that you did the work correctly. Secondly, you want to always show work, okay? By showing work, you will ensure that you do not make silly mistakes. Okay, so for this problem, I want to use the reference slides. This PowerPoint will be attached at the bottom of this video, so I want you to use the reference slides that are at the end of this PowerPoint. Now, if you're 2 years old, how many minutes have you lived? Now, before you begin this problem, remember, you want to ask yourself the question, what is the unit you are starting with, and what is the unit you want to end with? I'm going to give you some time to think about that because this is critical to getting the question correct. Now that you've had some time to think about it, you should have reached the conclusion that the unit that we're starting with is years, and the unit we're trying to reach is minutes. So what we want to do is start with what we have. So the unit that we have in the beginning is 2 years. And we want to use conversion factors to try and get closer from the unit we have, years, to the unit we want to get, minutes. Now, we do not have a conversion factor that goes straight from years to minutes, but we do know some conversion factors that will help us get closer to the destination. So what we can do is, we know that in 1 year, there are 365 days. So because of this, we can cancel out the unit years with this unit years so that we are now remaining with the unit days. Now, yet again, we are now have the unit days, but we want to get to the unit minutes. We do not have a conversion factor that goes straight from days to minutes. So what we want to do is get closer to the unit that we're going for, which is minutes. So what we can do is, we know that in one day there are 24 hours. So as you can see, yet again, the units here will cancel out. The days units will cancel out until we're left with hours on the numerator. So now we have the unit hours, and what we will have is when we multiply 2 times 365 by 24, that is how many hours we have in 2 years. Now we can finally use the conversion factor that will get us to our desired unit. We know there are 60 minutes in 1 hour, so we can cancel out the hours unit, and now we have 60 minutes. So all the units from this year unit was canceled out, the days unit was canceled out, the hours units were canceled out, and we are only remaining with minutes, which is our desired unit. So when we multiply this out, we get our answer, which is 1,051,200 minutes. These are the number of minutes in 2 years. Alright, now that we have done this problem together, I want you to try this problem on your own. Now remember, I want you to use the reference slides that are attached at the bottom of this video. So the problem is, if you eat 5 cakes a day and 12 days passes, and each cake costs 54 cents, how many dollars did you spend? Now here there are a lot of units, but with dimensional analysis, it's always the same thing. We want to first identify what is the unit that we're starting with and what is the unit we're trying to reach. I'm going to give you some time to think about that, and then we'll do the problem together. Alright, so you should have reached the conclusion that the unit that you're starting with is cakes, and the unit that we want to reach is dollars. So what we have to do is first start by writing 5 cakes and use conversion factors in the information that's given until we reach the unit dollars. Now I want you to try this problem fully, and we will go over the problem after I've given you some time to work on the problem. Alright, so let's go over the problem together. So, if you eat 5 cakes a day and 12 days passes and each cake costs 54 cents, how many dollars did you spend? So we're starting with the unit 5 cakes. So we have 5 cakes a day and 12 days passes. So if we're eating 5 cakes a day and 12 days passes, that means that in total, after 12 days, we're going to have eaten 60 cakes. And we have the unit cakes because the unit days. So let's go over the problem together. So if you eat 5 cakes a day and 12 days passes and each cake costs 54 cents, how many dollars did you spend? Remember, we're starting with the unit cakes and we're ending with the unit dollars. So we know that our answer is probably correct if at the end our unit is in dollars. Okay, so we're starting with the unit 5 cakes a day and 12 days pass. So this means that if we're eating 5 cakes a day and 12 days passes, then we have eaten a total of 60 cakes. We have the unit cakes because the unit days have been canceled out. Okay, we also know that each cake costs 54 cents. So what's going to happen is we have 60 cakes and each cake costs 54 cents. This means that the cakes units are going to cancel out. So we now are left with 60 cakes, each one costing 54 cents. But remember, we do not want cents as our unit. We want dollars as our unit. So we're going to use a conversion factor that changes cents to dollars. We know that $1 is 100 cents. So we can use this conversion factor to get to our desired final unit, which is dollars. And the unit cents cancels out. So as you can see, we started with the unit cakes, but through these conversion factors, we have reached our desired unit dollars. And when we calculate this, we get our final answer, which is $32.4. This means that if 60 cakes cost 54 cents each, that is equal to $32.4. And for our next section, we will have science applications with special guest Hannah. Yay! All right.
Hi everyone! So we're just going to go through an example where we apply dimensional analysis to a scientific topic. So here we have a soap dispenser. This is something that you might find at your bathroom sink that you're going to fill with liquid soap and use to wash your hands. So what we want to know is, can we use these dimensions to figure out how much soap? No, that's not what we want to figure out. What are we figuring out? Hi everyone. So we're going to do an example where we apply dimensional analysis to a scientific concept. So if you look here, we have a soap dispenser. This is something that you might find in your bathroom that you would fill with liquid soap to wash your hands with water. So we're going to use this soap dispenser and its dimensions to try to solve a dimensional analysis problem. So as you can read here, you are trying to buy a bulk amount of liquid hand soap for your soap dispenser to prevent the spread of coronavirus. Remember, the best way to prevent the spread of coronavirus is by regularly washing your hands with both soap and water. The least expensive way to buy the soap is in liters. Your soap dispenser has the dimensions shown on the left. If you buy 10 liters of soap, how many times can you refill the soap dispenser? So what I want you to do is pause this video and think about how could we solve this problem. So if you look back to this slide here, our soap dispenser has dimensions that are measured in centimeters, and our soap that we are purchasing is going to be in liters. So think about how we might relate those two units to each other and be able to get to an answer. All right, now that you've had some time to think about how to solve this problem yourself, we're going to go through it together. The first thing that we need to do is we need to find the volume of the soap dispenser in centimeters cubed. So how are we going to do that? Well, for a cuboid, which is what this shape is called, we are going to multiply together the length, the width, and the height. That's going to give us the volume in centimeters cubed. Here you can see, if we fill in those values, we have the volume of the soap dispenser is equal to 3 centimeters times 2 centimeters times 10 centimeters. This gives us a volume of 60 centimeters cubed. Next, we need to convert the volume of the soap dispenser to the same units as the volume of the soap. This means that we need to go from centimeters cubed to liters. This way, all of our units will be the same. So here's how we're going to do that. We're first going to take 60 centimeters cubed. We're going to convert that into milliliters. If you remember from science class, when we're converting from a solid to a liquid volume, we'll go from centimeters cubed to milliliters. So that's what we're doing here. We have a solid soap dispenser, we're filling it with a liquid. So we want to convert to milliliters. 1 milliliter is the same as 1 centimeter cubed. Then we want to convert to liters, which is the unit that we want. In order to do this, we need to use a conversion factor. We know that 1,000 milliliters is equal to 1 liter, so we will use that conversion factor to get our answer in liters. Okay, when we do that, we end up with 0.06 liters as our answer. What this means is that each time we refill the soap dispenser, it will require 0.06 liters of soap. All right, our last part is we need to then go from our 10 liters of soap that we have total into how many refills we can do. In order to do this, we're going to take our 10 liters of soap and multiply it by the conversion factor of 1 refill over 0.06 liters. Now, the reason that we have it structured 1 refill over 0.06 liters is, remember that you always want your units to cancel out. So if we start with liters on top, we need to cancel out the liters by putting them on the bottom. When we do this multiplication, we get to an answer of 166.67 refills. This means that with 10 liters of liquid soap, we could refill our small soap dispenser 166.67 times. So this soap dispenser here, we would be able to wash our hands for a very long time, which would be very good when we're trying to prevent coronavirus.
Now that we've gone over dimensional analysis, let's go back to the first problem and figure out who is the tallest. Now we have these four guys. The guy's 5'6", another guy's 64 inches, the third guy's 166 centimeters, and the last guy is 1.67 meters. We have four different units, so what I recommend you to do is choose one unit to change all of them into, and I recommend you choose centimeters, although you don't have to. So after you've finished this problem, I want you to go and click on the link below where there will be a quiz and you can find out if the answer that you calculated is correct. Now, thanks for tuning in today. I want you guys to keep up to date with the ASAP channel. I want you to subscribe so you can know when a video is released so that you can keep up to date with your learning and keep track of your competencies. Goodbye.